I'm going to do a video today comparing the action potentials in pacemakers with the action potential in the cardiac muscle itself. We've talked a little bit about this in a different video, so I'm just going to go over the cardiac muscle really quickly, and then I'm going to dive in and talk more about these pacemakers because they're actually really pretty fascinating. So cardiac muscle, we start out at a resting membrane potential of about negative 85 millivolts. We get a stimulus which causes our membrane potential to rise to threshold. At threshold, the voltage-gated sodium channels, potassium channels, and calcium channels are all activated. The sodium channels open first, get that upshoot as sodium rushes in and depolarizes the membrane. But then the sodium channels are inactivated at the same time. The potassium channels finally open. We get this depolarization or this repolarization. Finally, our calcium channels open. Calcium's going to flood in while potassium's flooding out. They oppose each other, so we get really no net flux of positive ions, which is what gives us this plateau. The calcium channels will then be inactivated, and our potassium channels take us the rest of the way back to resting membrane potential. Okay, so that's the cardiac muscle. Now let's talk about our pacemakers, okay? So when our pacemakers get to threshold, different from all of the other tissues we've learned and talked about so far, it's actually calcium channels that are activated, T-type and L-type calcium channels. T-type and L-type calcium channels are activated, and calcium goes into the cell, right, depolarizing the membrane, getting us up to here, and then those calcium channels are inactivated. Our potassium channels are then open. We get our repolarization. And when it gets down to about negative 65, something interesting happens. We have something called funny channels in these pacemakers. These funny channels are sodium channels, and they are actually different than other sodium channels because they don't cause this rapid influx of sodium. They cause a slow depolarization of the membrane back to threshold. And that is automatic. Anytime we get back to this negative 65, funny channels are going to open, bring us back to threshold, get another action potential. Now, there are 4 different types of tissues that have this pacemaker function, but only one is ever expressed at a time. The 4 tissues are the sinoatrial node, the atrioventricular node, the bundle of His, and Purkinje fibers. Okay. The way your body decides which one is going to be the pacemaker of the heart is whichever one gets to threshold the fastest. It's just like a race. Typically, physiologically, what we see is the sinoatrial node is the one that gets to threshold the fastest. It gets there about 70 to 80 times a minute. So about that fast, right? The AV node gets there between 40 and 60 times a minute. So it's a little slower. Bundle of His about 40 times a minute. And our Purkinje fibers about 15 times a minute. Right? So the Purkinje fibers are a lot slower than the other ones. They're the last resort. It's kind of just like a backup, right? We're not getting stimulus from our SA node, so let's make sure we keep that heart going using our AV node automaticity there, right? And vice versa, right? So that can keep going. That's all I wanted to say about pacemakers of the heart and comparing that cardiac muscle. I hope this video was helpful to you, and go ahead and subscribe, like my channel. Thank you very much.